This is 4.8, Math 1. We are now going to start talking about proving triangles are congruent. You have 5 different ways to prove that triangles are congruent. Go ahead and write down these 5 ways in the margin of your notes there. Side, 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 HL, side, angle, angle, side, and angle, side, angle. Okay, these are proving that triangles are congruent. Okay, 4.8 only deals with one way. What's the one way? Side, side, side. Okay, 4.9, which we'll get to in a second, deals with HL and side, angle, side. So right now, all we're doing is we're talking about one method. It's called side, side, side. Before we can talk about that, we need to talk about corresponding angles and corresponding sides. Okay? Before you can understand how we're going to prove triangles are congruent, you need to understand the idea of corresponding angles and corresponding sides. Okay? So here's your example on that. Triangle ABC is congruent to triangle XYZ. Okay? Copy this down. We're talking about corresponding angles and corresponding sides. Okay? Here is triangle ABC. Okay? Triangle ABC is congruent to triangle XYZ. You have the congruent statement. Now we have the diagram. We're going to fill in this diagram over here. If you look at the congruent statement, what does angle A have to be congruent with? Angle X. Angle A is in the first slot. Angle X is in the first slot. That's not by mistake. Order matters. So if we're talking about angle A down there, then angle X has to be right there. They are corresponding, meaning they have the same measure. If angle A is 60, then angle X has to be 60. If angle A is 100, then angle X has to be 100. They are congruent. So if this triangle is congruent to this triangle, then angle A has to be congruent to angle X. Okay? By corresponding angles, corresponding sides. Okay? Angle B is in the second slot. What's in the second slot over here? Angle Y. So where does Y go? Right there on the top. Angle Y goes on the top. Same thing for C. What does C match up with? Z. So I put a Z right there. Okay? So that takes care of our corresponding angles. On the test, they might say, which angle corresponds to angle B? And you would say angle Y. Piece of cake. Okay? Now let's talk about our corresponding sides. Alright? Side AB, right here, side AB has to match up with what side?
XY.
XY. Here's XY. AB is 5. XY would have to be 5. AB is double slash, like that. Then XY would have to be double slash. Okay? They are corresponding. BC has to match up with what? YZ. Look at it. BC and YZ. They have to match up. BC and YZ have to match up. I'm just putting one slash there. You get the idea. Okay? What else? AC, look at it. A, the first letter and the last letter, AC has to match up with what? XZ. Look at it. AC and XZ. So it might say which side corresponds to side BA. And what would you say? YX or XY. Does order matter when you answer that like that?
Probably.
No. No. You could try to match it up, but as long as you get this right 2 letters, you're okay. Now, does order matter when I say triangle ABC is congruent to triangle XYZ?
Yes.
Oh yeah. Order matters big time. I could give you the drawing like this and ask you to write the congruent statement. I could give you the congruent statement and ask you to do the drawing. Okay, these are all possible type questions. Any questions on corresponding angles or corresponding sides?
What are those last 4 again?
These triple slash,
Yes, sir.
double slash, that's just a way of saying that this was 3 and this was 3. Or this was 8 and this was 8.
Oh, okay.
When they don't give you the side measurement, they put the slashes there. Yeah.
Could AB side and BC side both be double slashed?
Sure, it'd be isosceles triangle.
And if they were all three, it'd be equilateral triangle?
Mm-hmm.
Does this mean that we know it's not an equilateral?
You know it's not an equilateral because 1, 2, and 3 indicate different numbers. That's right. Scaling. That's right. All right. So enough about that. Now let's talk about proving triangles are congruent. What are your 5 ways? This one is side, side, side. This is HL. We'll learn about it in a second. This is side, angle, side. We'll learn about it in a second. These two we'll learn on Wednesday. Okay, this is section 4.10. Side, side, side. Let's talk about it. Question. Can I prove that these two triangles, triangle 1 and triangle 2, are congruent?
Yes.
Sure. As is on the board,
No.
can I prove that triangle 1 and triangle 2 are congruent?
No.
No, you gotta put some things.
I don't know enough information. Okay? What do I know about triangle 1 and triangle 2?
They're triangles.
They're
They
right
make a
triangles.
rectangle.
No, we don't know
Oh,
that.
because they got a little
They're
box.
adjacent.
They're triangles.
They're adjacent. They're side by side. They're adjacent. What else? They share a side. Right? The diagonal of the rectangle, right, is a side that they share. I know that triangle 1 has that side and triangle 2 has that side, and by definition it has to be the same. So can I now say side, side, side? Can I say yes, these two triangles are congruent?
No.
No, I don't have enough information.
You only have S.
How about now?
No.
Can I prove that triangle 1 and triangle 2 are congruent now? No, why not?
Because you don't
We only have side,
We
side.
don't have side, side. That's not one of my 5 ways. Okay, side, side is not a way. Now, can we prove that the triangles are congruent?
Yes.
Yes. Now and only now. Okay? So now you can say yes, the two triangles are congruent. Okay? Why? Because I have one side congruent to the other side. I have one side congruent to another side, and this side they share. And the way you say that is, that side is congruent to itself. Okay? The diagonal is congruent to itself. Okay? Side, side, side. It's the easiest one. You have to have all 3 sides congruent to all 3 sides. Okay? Let's do another example. Can I prove that these two triangles are congruent to one another?
Yes.
Yes.
No, it's only side side.
But they
the
share
middle
a side.
thingy.
But you're missing.
How do we say this? The middle line is congruent to itself. Both triangles share that side. So I do this in my head and I say, yes, these two triangles are congruent. How are they congruent? By what reason?
Side, side, side.
Side, side, side. Side, side, side. You have all 3 sides congruent to all 3 sides. Okay? Questions? Any questions on congruent angles? Any questions on or congruent angles, congruent sides? Any questions on side, side, side? All right, let's go ahead and talk about HL. What do you think has to be congruent in order for me to prove HL? I've got to have one right triangle and I have to have another right triangle. In order for it to be HL, both triangles have to be a right triangle. Write that down. That's your first step. If they're not right triangles, then obviously it's not going to be HL. Both triangles have to be right triangles. Let me say it one more time. In order to prove HL, the very first step is that both triangles have to be right triangles. If one is a right triangle and the other one's not, no dice. Okay? It's not going to be HL.
Hey, what does HL stand for?
Hypotenuse-leg. Now let's talk about that. We got 2 right triangles, right? We're looking for a hypotenuse-leg. That means that the hypotenuse of one right triangle has to be congruent to the hypotenuse of the other right triangle. Okay? Has to be. You don't have a choice. HL. Okay? What else has to be congruent?
One leg.
Does it matter which one? No, it does not. One leg has to be congruent to the other leg. Now, as you see it, you would be able to say, yes, the two triangles are congruent by HL, hypotenuse leg.
Okay, so if you had the little tick mark on the longer leg and you had 2 on the bottom one, you would like not be able to tell if it was congruent or not?
Okay, this isn't a longer leg. The hypotenuse is always the longest side. But I think this is what you're asking. If you had this, would you be able to say HL?
Yes.
No.
Like, but you didn't have
Hold on, one at a time.
Have that thing at the bottom.
Would you be able to prove HL if you had this?
Yes.
No.
No.
Why not? Because you don't know the hypotenuse.
But it's
But the
gotta be the
hypotenuse
same.
You gotta
has
know.
to be the same.
You gotta know.
All right, y'all are right,
the thing.
right?
But you can't prove it by hypotenuse leg, but it is congruent.
What's another reason?
Side.
Just prove my next statement.
Okay.
Side angle side is another method. So not only do you have to be able to tell me that the triangles are congruent, you have to be able to tell me the reason. Side angle side is a way. Look at it. Side angle side. The most important thing about side angle side is where does the angle have to be? And we call that the included. Okay? It is the included angle. It always has to be side angle side. Okay? Side angle side. Write that down. The angle has to be in the middle. Or you could say the angle has to be included. Okay? You've got a side, you've got another side. The angle has to be in the middle on both triangles in order for you to be able to say side angle side.
Where else was the angle?
One at a time. One at a time. Yes? Raise your hand if you have a question. All right, let me do a few examples, Scarlett, and I think you'll understand. All right, here we go. All right. What about these two triangles?
Side angle side.
Just a second. How so?
Because those two angles are the same because of the middle.
It's hypotenuse-leg.
We don't know right triangles, so it can't be HL.
It can't be side angle side either.
Why?
Yeah.
Because the hypotenuse isn't side.
Quit saying hypotenuse. There's no right triangle up here.
Or
The diagonal is
Diagonal.
congruent to itself.
oh, so it's
So I have side, angle, side, and I have side, angle, side. So can I say that these two triangles are congruent?
Yes.
Yes, I can.
How do you know that?
How do I do what?
How do you know that?
Side, angle, side, angle, side.
It does have to be the same angle.
So,
That's what the arc means, that they're congruent.
How else would the angle not be in the middle?
If you
We
be
just put some
patient,
more-
I'll show you an example, a counter example. Be patient.
Is this the fourth one?
It's a virtue.
I don't have that.
I like it.
We're still talking about these three methods. We're not learning these two today.
Okay.
We're just talking about these three methods.
This is all for
Okay? This is 4.8 and 4.9. I went ahead and did 4.9. Okay?
4 9.
I need this for note card decision.
Okay.
What?
Let's talk about this. This is a classic bow tie problem. Okay? You'll see 1,000 of these. The first thing you should think of when you see the bow tie problem is what? What's true about these two angles?
They're the same.
They are congruent. Why are they congruent?
Vertical.
They're vertical. Very good. So this angle is congruent to this angle. They're not going to tell you that. You have to realize that, or you have to recognize that. That they are vertical angles and they're going to be congruent.
Top and bottom.
No, you don't know any other angles. On a bow tie problem, unless they give it to you, you don't know any other angles. Okay? So now, would you be able to prove that these two triangles are congruent?
Yeah.
by side, angle, side?
Side angle side.
Side. Chill.
No, between them.
Hypotenuse leg.
Say it again, listen back. Everybody listen. Pay attention.
Because it's not between the two lines.
In order to be side, angle, side, where does the angle have to be? In the middle. We have SSA or ASS, however you want to look at it. And there are no bad words in geometry. SSA and ASS are not one of our 5 ways. Write that down. There are no bad words in geometry. Okay? Angle, side, side, thank goodness, is not one of our 5 ways to prove that triangles are congruent. Same, side, side, angle. It's not one of our 5 ways. Look at it. Side, side, angle. Angle, side, side. This is not, we cannot prove triangle congruence. So the answer would be simply no. They're going to ask you, they're going to say, are the triangles congruent? And if so, state one of these 5 ways. Okay, Scarlett, did that answer your question? Did that help you? Okay, good. Questions? Mooney?
Is HL, like, since it's only dealing with right triangles, excuse me, so like if you see a problem with a right triangle, can you instantly assume that it's going to be HL?
Great question. Let's look at that. All right, Mooney wants to say instantly that it's HL.
No.
What's H?
I think it is.
Whit says it is.
There's only one right angle.
No, I think it's.
But they
side
share the
side.
same wall.
Hold on. Let's address John's question first. He says there's only one right angle. Is that true?
No, because they share the same wall.
No. They're
I
a
think
linear
close
pair. And if this one is 90 degrees, then what does this one have to be?
90 degrees.
Has to be. So it's understood that both of those are 90 degrees. So that takes care of that. Both triangles are right triangles. Okay? Can we say HL? We're still back to our original question. Can we say HL?
We don't have the hypotenuse.
We don't have the what?
Hypotenuse.
Hypotenuse. Right? We have a leg and a leg. We have another leg congruent to itself. So can we say HL? No, we cannot.
Side angle side.
What can we say though?
Side angle side.
Does side angle side work in this case?
Yeah.
Yes, it does. Look, side angle side. Side angle side. Okay, so it works. So your reason would be side angle side. Please don't talk. Okay. Say that again.
The side angle side can that work anyway, like the 1 to the 2 instead.
I'm not understanding your question.
Like I was thinking about side angle side stuff for like I was doing the short leg to the long, the one that shares itself. Yeah. Or do you have to only do long?
I don't know what you're asking. I can't get a question out of that. But it always has to be side, the included angle, and side. Okay?
But Coach Collins,
Yes?
explain to me how the hypotenuse is not the same right there.
Oh, it is. Once we prove that triangles are congruent, then by corresponding sides, you would be able to say, if you know that, right, then after you say that this triangle is congruent to this triangle, then you would know that those are congruent. Look, it stands to reason that if the triangles are congruent, you're going to, now what could you say? Besides this and this, what else could you say?
Side, side.
Right, but you have to go on what the information they give you so that you can state the correct reason. It's kind of like a flow. You can't jump to step number 8 if you're only on step number 2. Okay? Questions? Yes?
Will we have to do like 20 note cards for this?
You have to do 20 note cards, 10 for 4.8 and 10 for 4.9.
HL and SAS are
So we're doing 4.9.
4.9.
That's right. And you can look in your book.
Yeah, bro.
I hate
Are we done with notes stuff?
No, not yet. Stay with me. All right, how about this one?
No. That won't work. The answer's no.
Hypotenuse leg.
because it's
Oh, no, never
Yeah,
mind.
but it's
No, because the
No.
angle is not equal.
The bottoms are the same.
All right, choose a side. Some of you are wishy-washy. You say yes, and then you turn around and say no.
they could be, but
Is it yes? Raise your hand if you think it's yes.
Dustin.
Dustin's the only one?
You,
Alright.
I'll stick
Tell
with
me
you.
why, Dustin.
Because on the first one, the bottom and the right are the same. So
This side is congruent to this side, which gives you a,
side.
what kind of triangle?
Isosceles.
Isosceles triangle. And in every isosceles triangle, these legs are congruent, and what else is congruent? These base angles. So because they told you that that side and that side are congruent, you know that this angle and this angle are congruent. Okay? That's something that you may or may not have known about isosceles triangles. Now you know. Okay? Now hold on. Now come over here to this triangle. What you got on this triangle?
Since the bottom and the bottom are the same, that means the right is also the same.
Can't make that jump. You don't know that this is the same.
Shut
You don't.
down.
You don't know.
I think that they are, but we don't have enough information to prove it.
They're not congruent. This one is angle, side, side, no matter how you look at it.
I'll say
You
what's
don't
up.
have the included angle, and this one is side, angle, side. Okay? So I'm going to do it like this so it looks a little better. In case somebody walks in the door. Side, side, angle, right? The angle, no matter what we did, was not included. Okay? Even though it was isosceles, even though I was able to say that this was congruent to this one, right? I was able to make that jump. I don't know that third side. Okay? Same thing over here, except for now I do know that side and the included angle in the side. So I did have side, angle, side on this one. Okay? Questions? All right, let's do one more and then we're going to do some examples out of your book. What's the time on it, Lipsy? Does it say?
You got like 7 minutes left on it.
Okay.
Coach Howard, this camera like keeps blurring out of focus.
Yeah, it has some autofocus feature on it.
Yeah, I noticed on the videos it does a lot. And
I-
like, you can't read
But when I'm standing here, it sees me and it focuses back. So I try to stay in the frame.
Well, you're blind right now, now you're
Okay, it's better.
It's better. It does. It goes in and out. I'm gonna have to.
Yeah, when I was watching those videos too, I noticed it.
So were you saying that's the
Can
right
I,
triangle?
the next one?
That's a box.
Alright.
You ready?
Yeah.
Alright. Well, since you know that that is a right angle, correct? You know that the other one is right angle.
By what reason?
By vertical
Vertical angles.
Vertical
Here
angle.
and here.
Yeah,
Okay.
and then also, you know that 1 and 1 are congruent because it says so, and 2 and 2 are congruent because it says
This
so.
side is congruent to this side.
Yeah, and 2 and 2 is congruent to that side to that side, and then so by you could do side. No, you could do hypotenuse-leg, and that's how you can figure it out.
Yes.
Are you sure about that?
Yeah.
I am.
Do we have HL on these two triangles?
Yes.
Yes.
Do you have this?
Yes.
Yeah, that's what I was saying.
Side, side angle or angle, side, side. Do you have that?
Yes.
Yes. These aren't one of our ways. If I hadn't told you that this was a right angle, the answer would be no. The only way that these two triangles are right triangles is because I made that a right angle. You do have HL. HL works only in this case
Good job, John.
because they're right triangles. They have to be right triangles in order for you to have HL. Okay? Questions? Dustin?
So HL is only with right triangles?
That's right. HL, hypotenuse. The only time you get a hypotenuse is when it's a right triangle.
So it wouldn't be side, angle, side?
Side, angle, side? No, it wouldn't because you don't have side, angle, side.
Oh.
Or
yeah.
side, angle, side. Angle has to be in the middle. Okay? All right, questions? Yes?
So a hypotenuse wouldn't count as a side?
Yes, it counts as a side.
Okay, so
It counts as a side.
So if it was side, angle, side, or something,
Side, angle, side.
but why wouldn't you count the bottom?
Because this angle's not included. In order to be side, angle, side, it has to be side, angle, side. The angle has to be in the middle. Okay? Mooney, do you have a question?
I do.
So if they were to throw up a triangle with like no lines or markings on it, you can just say no.
Just say no.
I got a joke.
Say no
You
to
could
no.
say no. But let me ask you this. What does every single one of these have at least one of?
Side.
An angle.
You've got to have a side, right? This one doesn't have any angles. But on every single one of these, you have to have at least one side.
So if it just gave you one angle, you couldn't do anything with it,
Yeah, you could. Could be one angle, could be side, angle, side.
What if
It could be HL if it was a right angle.
you can't have angle, angle, angle?
No, you cannot.
Why?
Angle, angle, angle is similar.
Oh,
Angle,
because
angle,
that
angle
could
is
be
similar.
longer.